This sorter algorithm is called a heap sort, and it utilises something that we call a max first heap. That is a data structure that is a bit complicated, but I'm going to go through the heap before I go through the sort, because actually the sort is, if you like, done all by itself through the process. A heap is a special type of tree structure which starts with a single node, then 2 nodes under it, then 4 nodes under that, etc, etc, etc. So what we're going to do is we're going to start by creating our heap, and I'll explain what makes a heap different to a standard tree as we go. So we take our first item on our list, which is a 6. Now, a max heap means that the items on the top, the parent items, must always be larger than the children. Okay? So the next item is a 7. Now the first rule is that I've got to put it to the bottom left of this row, and the next item should go to the bottom right of this element. But obviously this violates the original item that I just said, where I said this has to be the largest item. So every time we add a new item, we then have to run an algorithm that says, is this larger than its parent? If it is, flip the 2 items. And then we then need to do the same on this with its parent, but actually this is the topmost node, so there's nothing else that we need to do. We then take the next item. In this case, it's a 10. It has to go here. Is it larger than its parent? It is, so we have to flip it again. And there's no parents in 10, so that's fine. The next item has to go down here, so the next item is a 4. Is 4 smaller than its parent? It is, so it can stay where it is. 2 then goes next. 2 is smaller than 6, so that's fine. Let's move these across a bit. 5 is 5 smaller than 7? It is, so that's fine as well. Ace, that's fine, so that can go there. Now we're going back down to the next row. So we're down here, 3 is 3 less than 4? It is, so that's fine. Then we go to the 9. The 9 goes to the right of 4. Is 9 smaller than its parent? It isn't, so we have to do the flip. Then we have to check this against its parent. Is 9 greater than 6? It is, so we have to do a flip again. And now is 9 greater than 10? It isn't, so we can leave it where it is. The final card is going to go all the way down to the bottom here on the 2, so let's move these across even further. And again, it's 8 greater than 2? It is, so it needs to flip. Is 8 greater than 9? No, so therefore we now have a fully functioning max first stack. So 10, children are 9 and 7, then we've got 6, 8, 5, ace, then 3, 4, 2. So how does the sort algorithm work? Well, it actually sorts in reverse order, and the way it works is to take the top element of the stack each time and put that to the end. Now we need to move and merge one of these 2 items to become the new top of the stack. Well, the 9 is obviously larger than the 7, so the 9 flips into this position. So now the 9's the head. We've still got no head here. Then we have a look at the 6 and the 8. The 8's obviously greater, so that flips into that position. And the 2 can't go into the position of the 6, it comes into the position of the 2 here. So now we have a new stack where 9 is at the top of the stack. That then obviously goes into the order. We need a new top out of the 2, 8 and 7. 8 is the highest. Then we look at the 2. Well, 6 is higher than 2. That now comes further down. 6, the 4 and the 3. The 2 now moves down to the bottom, and so on and so on and so forth. So by taking the first element of the stack and then reorganising the stack each time, literally it will go into the correct order. And we have a stack sort. Sorry, a heap sort, not a stack sort.